Hello, geometry family. Welcome back. So, what is that? My computer's typing things. I don't want it to type, but this is just a mess today. Hopefully, that does not ruin everything else. So let's see if these troubles keep happening. Today we are going to talk about some coordinate geometry proofs. And yes, we are kind of skipping ahead here. I know it says day 14, and that's where I want you to be. But we're jumping ahead for a reason, I promise. And so what we're going to do here is I'm going to make this video as short as I can to get the main point across. Because if I were with you, I'd make a big story about this and we'd work up to it. I don't have that kind of time, and I don't want you to have to stare at my face for that long. So we're going to do it the quick way. You learned about slope, distance, and midpoint formula. Why? Because it's useful. How is it useful? To justify and prove what things are. So you look at something and you go, I think that's a square, but I'm not sure if it's a square. What's going to help you? Slope, distance, or midpoint. And that's what we're getting at. So, proving quadrilaterals with coordinate geometry. We're on page 15 if you haven't gotten to me yet. All right, proving quadrilaterals with coordinate geometry. How do you prove something as a parallelogram? Technically, there are a buttload of ways. At least five different ways to prove it's a parallelogram. You don't need 5 ways. If you're doing it with coordinate geometry, even though there's going to be lots of ways to do all these things, I'm just going to list the easiest ones. You're welcome. Parallelogram has the word parallel in it. So to prove something as a parallelogram, you are going to calculate all 4 slopes, because slopes tell you if things are parallel, because you want to look for 2 pairs of equal slopes. Because if you have 2 pairs of equal slopes, that means you've proved that opposite sides are parallel. Okay? What if you want to prove it's a rectangle? Well, if you want to show something's a rectangle, the base definition of a rectangle is a quadrilateral with 4 right angles. If something has right angles, its sides are perpendicular. What formula proves perpendicularity? Slope again. So if you want to prove something's a rectangle, you again want to find all 4 slopes, and you want to look for pairs of opposite reciprocal slopes. What if you want to prove it's a rhombus? Well, a rhombus is a slanty square, and the basic definition of a rhombus is any quadrilateral with 4 congruent sides. Well, congruence means that the sides are the same length. Length comes from the distance formula. So you're going to do 4 distance formulas, or Pythagorean theorem, whatever you want to call it, but basically find 4 lengths, okay? And look for 4 congruent sides. Then, last but not least, and technically last is the most, if you want to prove that something is a square, you have to show that not only does it have 4 equal sides, but it's got 4 right angles also. So you need to do both 4 slopes and 4 distances to show that you have pairs of opposite reciprocal slopes and 4 congruent sides. All right. I apologize for the crappy handwriting I have in there. Hopefully you can read it. Quick recap before I move on. Parallelogram. You got to prove things are parallel. Find 4 slopes. Rectangle. You got to prove things have 90-degree angles. 4 slopes. Rhombus. It's just got to have 4 equal sides. 4 distances. Square. Got to have both the slopes and the distance. And that's it. All right. So let's turn to the next page. Prove this quadrilateral is a rectangle but not a square. All right. So if I want to show that this is a rectangle and not a square, you might be thinking, duh, Mrs. Viver, it's not a square. You're right. You can see it, but we're not just going off our eyeballs here. We're going to do what it says. So if I want to prove that this is a rectangle, okay, I want to show that we have 4 perpendicular pairs of sides, okay? And if I want to show that it's not a square, I want to show that I have pairs of sides that aren't equal. So sides not all congruent. So which formulas is that going to take? Well, to show something's a rectangle, I would need slope. And to show that something is or is not a square, I would need slope and distance. So now we're just going to do that. And I'm going to say, all right, I want to show that this is a rectangle. Fine. I need to do slopes. Fine. Slopes. What should I start with? Well, let's just start with GH. To get from G to H, I go up 2, right 4. So the slope of GH is up 2, right 4, which reduces to a half. Reduce your slopes. All right, what comes next? HI comes next. Well, let's see. HI going to go up 2, left 1. So that slope is 2 over -1 or -2, whichever way you want to look at it. IJ. So if I go from I to J, I'm going to go, let's see, up 2, right 4. And then JG, down 2, right 1. And that's the same as -2. Okay, so there's my slopes. It said I'm supposed to use slopes to prove it's a rectangle. Well, let's see. If I want to show that things are perpendicular, I want to look for opposite reciprocals. And 1/2 and -2 are opposite reciprocals. And it's easier to see if you look here. I flipped it upside down and negated it. 1/2 and -2 are opposite reciprocals. So I know that I have perpendicular sides. And all I got were 1/2s and -2s. So I'm going to have a conclusion statement that GHIJ is a rectangle because adjacent sides have opposite reciprocal slopes, making them perpendicular. Your conclusion needs to have 3 main parts. What is it? Okay. What formula did you use and what did you notice about that formula? So I noticed equal slopes. I noticed opposite reciprocal slopes. And then last but not least, what do those slopes tell you geometrically? They tell me that I have things that are perpendicular, giving me right angles. Okay, cool. I proved it's a rectangle. Now, if I just want to prove it's not a square, I just want to look at the side lengths and show that 2 of these side lengths aren't equal. So I'm going to find the side length of JG. All right, and I'm going to do this using the Pythagorean theorem. So that's 1, that's 2. 1 squared plus 2 squared equals c squared. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. So JG is the square root of 5. Now I'm going to do JI. So that's 2, 1, 2, 3, 4. 2 squared plus 4 squared equals c squared. 4 plus 16 is 20. So c is the square root of 20. Well, the square root of 5 and the square root of 20 are not the same. So then I can come down here and say it's not a square because the 4 sides aren't all congruent. Okay? That's how you do a coordinate proof. You look at it, you decide what formulas to use, you use them, and then you write a conclusion. All right? So let's come down here. PQRS, they want us to prove that it's a square. Okay, if I want to prove it's a square, I need to do 4 slopes and 4 distances to show 4 congruent sides and 4 pairs of perpendicular sides. So I'm going to use slope and distance formula. All right. And now I'm just going to do my work. Cool. So slopes. PQ, QR, RS, SP. All right, slope from P to Q, up 3/4. Up 3, right 4, 3/4. QR, down 4, right 3. RS, down 3, left 4, so that'd be -3/-4, which is just 3/4. And then PS, down 4, right 3, -4/3. All right, what do I notice from those slopes? 3/4, -4/3. 3/4, -4/3. Since the slopes are opposite reciprocals, we know adjacent sides are perpendicular. Okay. Now I'm supposed to do distance. All right, so my distance formula, well, I already kind of counted this. That's up 3/4. And if I were to draw the rest of these in, I'd have a bunch of 3s and 4s. So to make my life a little bit easier, if you draw it on the graph like I did, you're showing me that you notice all those triangles are going to be the same. So I could do the distance and say, you know what, I'm going to do all 4 sides the same way. 3 squared plus 4 squared equals c squared. And all of them are 3/4. 3 squared is 9, 4 squared is 16, 25 equals c squared. C would therefore be the square root of 25, making C 5. Since all 4 distances are equal, 4 sides are congruent, therefore it's a square. What did I do? Do I have the 3 parts? What is it? What formulas did you use? What did you notice about them? And then what does that mean geometrically? What is it? Formula with noticing. What's it mean geometrically? I have it all. So that's a good conclusion. All right, here's snow. Find the coordinates of W, make it a rectangle, and prove it's a rectangle. All right. So let's plot this. -4, -2, there's S, 2, 6, there's N, 6, 3, there's O. All right, and if I want a rectangle, W's got to be down here somewhere. We're just going to count it. Because however I get from N to S is the same way I should get from O to W, right? So if I wanted to get from N to S, I'd go down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Looks pretty good to me. So that's the point 0, -5. So W is 0, -5. And they want us to prove that snow is a rectangle using coordinate geometry. Well, if I flip back 2 pages, we would say I know something's a rectangle if it's got 4 right angles, which means we need to do 4 slopes. Fine. So my slopes, SN, NO, OW, WS. And again, I have a picture, so I'm just going to count my slope. I could use the slope formula, but I mean, why not count it? To get from S to N, I'm going up 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So up 8, right 6, which reduces to 4/3. NO, down 3, right 4, negative 3/4. Ooh, I'm seeing opposite reciprocals. OW, down 8, left 6, negative 8 over negative 6, another 4/3. And then WS, down 3, right 4. I see opposite reciprocals. So snow is a rectangle because the 4 slopes were opposite reciprocals, making adjacent sides perpendicular. And that is it, my friends. Do I have the 3 parts? What is it? What formula did I use and what did it show me? And what does that mean? I'm good. All right, so that is your video for today. If you are watching this and you are part of cohort A, I want you to follow this up by doing the homework for day 14, which is just some property stuff that goes with this. So just do the homework for day 14 if you are in cohort A. If you are in cohort B, you do not need to do the homework for day 14 because we're going to talk tomorrow about a lot of that. So I hope everyone is having a great day, continues to have a great day, and I will see some of you soon.